Normally, in today's lesson, I'd be handing out an HCSRO4, this little device here that gives eyes to your board. In fact, it doesn't give eyes to your board nearly as much as it gives ears to your board, because this is an ultrasonic rangefinder. And right now, as we record this little video, it is sending out pulses of ultrasonic sound bouncing off this old hard drive right here and returning to the board and measuring the time it takes for that sound to travel, allowing it to calculate how far away the hard drive is. So if I pick this up and start moving the hard drive further and further away, it says the hard drive is now 23 centimeters away. And if I follow that ruler right down, that's a reasonably accurate measurement for bouncing sound right off of there. The other things that we've integrated from our board are the LCD display to show what's going on, and the Neopixels. As the object gets further and further away, more pixels come on, creating a bar graph where every 10 centimeters turns on an LED, and every 10 centimeters closer turns it off. The HCSRO4 is a really cool rangefinder sensor that's available online for fairly cheap. But since we're not together today, we're going to use one that's even less expensive. We're going to use a virtual one. So let's go online.
And thanks to the magic of video editing, we're now online. And you're looking at standard web browser showing us the site www.tinkercad.com. And TinkerCAD is a great site. It's been created by AutoDesk, and it's for people learning to explore and make and do things. Reasonably popular in schools. One thing you do have to pay attention to is privacy concerns for your students. If you're working with a class of high school students, you may need to get their parents to sign off giving them permission to access TinkerCAD as part of their school project, because personal information may end up being stored on servers outside Canada. Okay, so you can scroll through the page and you can see all the cool things that it does. It's got 3D modeling, it's got electronics modules in it, and we're going to explore some of the electronics modules, not surprisingly today, particularly the Arduino simulation capabilities. So if you haven't joined up, you can join in right now. And if you already have an Autodesk ID, so if you've downloaded any other Autodesk software, Fusion 360, AutoCAD, if you're an educator or a student at a registered educational institution, you should be able to set up your Autodesk Students account, log in, and just log in with your username and password. Oh, password. Password. There's so many passwords out there. All right, now there's when you log in, you probably won't see all this because this has some designs that I've used just for doing little demonstrations of the 3D modeling abilities and 3D editing abilities of Fusion. Of TinkerCAD. Not quite as sophisticated a product as Fusion 360, but designed for beginners to be able to get started fairly easily on. Now, when you're logged in here, feel free to play around with the 3D designs, but we're going to immediately jump over into the circuits. So just come down here and click on circuits, and you can see I've created some circuits in the past here, and we're going to create a new circuit. And bang, now all of a sudden your screen comes over here, and on this side of the screen you've got a whole list of components that you can access. Now, for some of the things that we're going to be doing, rather than just using the basic components, you can tell it you want all of the components, and then you can see everything that Fusion 360 has available for everything that TinkerCAD has available for you to use. So we come down here and there's breadboards, there's microcontrollers. You can even throw oscilloscopes in to analyze the signals. It's really, really quite amazing. While you're scrolling up and down there, let's take a look at our Arduino units. And when you pick on Arduino, that's pretty handy because it comes up with an Arduino that's already hooked up to a breadboard. And you can just drag that onto your screen right here. Bang. And there you go. So this is a really neat way to be able to build and test circuits in a virtual environment. And you can see you can move a few things around there, and the wires, once you get them plugged in, stay attached. We've got our 5-volt line right here that comes around to our positive header on our board. And we've got our ground line that comes along here to our ground. And of course, it's all nicely coded, red for positive and black for ground. Okay, well, let's see what else we can add to it. Let's come back to all of our components here, and let's just turn an LED on and blink an LED. So we can bring a resistor over here, and you can drag it onto the board like so. You can set the value for your resistor, 1K ohm. Let's set it to ohms, and let's set it to 100 ohms. And then we can come down here, and somewhere in this list we will find an LED, and you can drag the LED in, and notice the LED shows you the flat side. Okay, so the flat side is going to be your cathode side, and it's marked on there. Anode's your positive side, cathode's your negative side, and we can hook that up right there. So now that one is connected right there because they're in the same set of 5 holes. And we can add a wire right in here. Just click on here, and let's bring it down to pin 3. And we'll leave that wire in green, so electricity will come up from here, flow through the resistor into the LED, and then we are going to run a line. Can't quite get in behind there. Let me get in there. I'm going to run a black line into ground and make sure my LED's back on there. So pin 3 will send electricity into the resistor. The resistor will cut back the current so we don't burn out the LED. It'll flow through the LED and come back to our Arduino through ground. So turning pin 3 high should turn the LED on. Now, in order to make that happen, we have to come in here and we have to create some code. And to get the code, you click on the code button, and they have some nice pre-built-in examples right here. So this one turns the built-in LED to high and to low. And so we can just start that simulation right there. And that's running right there. And you can see right down here that the built-in LED connected to pin 13 is turning on and off. We're going to stop that simulation, and we're going to change the built-in LED. We're going to set, we don't want the built-in LED, we want set pin right there. Drag that down there. We set that on pin 3 too high. And set pin 3 to 0. Oh, that's the analog function. Just want to get rid of that. Set built-in LED, not built-in LED, set pin 3 to low, and then bring our code back together right there. It all joins together. And now if we start the simulation, you can see that in addition to having the built-in LED blink, we've got our own LED blinking. Now, something that's pretty cool about this is although you're using blocks to put this all together, at the same time, it's actually generating code. And what's really cool is because we've got blocks here, if we stop the simulation, you can, instead of looking at it in terms of blocks, you can take a look at it in terms of blocks plus the corresponding text. So you can drag these blocks right up here and you can say, okay, what's going on here? Set built-in LED to high. There's the words that execute that command right there. And here's the words, set pin 3, digital write 3 high. There's our delay right in there. So everything you're doing with the blocks is just a fancy way of actually writing the code. And you can also come over and you can just have it switch directly to text and continue. And now you can come in here and you can edit this code using the keyboard without having to worry about the blocks. So you can go in and add your own comments and set it up the way that you would in the standard Arduino IDE. Hugely, hugely powerful what we're going to be able to do here today. Okay, I'm going to delete all that. And I'm going to come over here and I'm going to get rid of the LED. Get rid of the code window so I can see a bit more on there. And you should be able to just press the backspace button, delete some of these things that we put on here. So we're back to having a board. And like I say, that was just highlighting and pressing the backspace button gets rid of the parts that I don't want. So we want to take a look at an HCSRO4 ultrasonic rangefinder. And you can see that there's two different ultrasonic distance sensors in here. And the darker blue one right down here is the HCSRO4. And we're just going to drag that onto our breadboard and put it about right there. Okay, and that board is going to need to be hooked up to power and to ground. So I'm going to hide some of that wiring right behind it here. So on this side, I'm just going to run a wire right there. And because it's connecting onto the power side of the board, I'll make that red. And on this side of the board, I'm going to run it into the ground side. And because that's going to ground, I'll make it black. So now I've got power right there and ground right there. So if I bring the HCSRO4 over here, you can see that the VCC symbol lines up with the ground, lines up with the red, and ground lines up with the black. Okay, now on your board, the one that we're working with in the real world, you've got two pins called trigger and echo. And looking carefully at my board, I see that the trigger is hooked up to pin digital 2 and echo is hooked up to digital 4. So I'm just going to come in here and I'm going to run a wire right from there down to digital 2. There's the trigger and I'll leave that in green. And the echo is going to come to digital 4 and I'm going to set that up in orange just so we can see the difference right in there. So those two are hooked up with some nice little jumper wires right in there. And that's all that you need to do to get the HCSRO4 working. Well, that and a little bit of code. Now, the trick for getting the code working is to do a little bit of Googling. The HCSRO4 is a really well-known sensor. And the great thing about working with Arduinos is that there's thousands and thousands of sensors out there that have been really well documented. So I've already got a window that came up right here. And if you do your Google there, you'll come up with one, the Random Nerd Tutorials, and it talks about the HCSRO4 sensor. Okay, really nicely written tutorial, gives you some nice shots of it and how it works, explains some of the details behind it, and shows you what's going on as it emits an ultrasonic wave, a sound at a high enough frequency that the human ear can't hear it, kind of like bats and other animals do, bounces back here, and you measure the length of time it takes that sound to travel, because we know how fast sound travels in the air. So here's a little schematic they've made up. Looks probably pretty familiar to what you're doing. It's got the pinout on there. And here's some code in their section. So again, just Google HCSRO4 or go to randomnerdtutorials.com and take a look. You'll find this code right here. Lots of other sites have very similar code, and you can just take that code. Make sure you scroll to the bottom of the window. So it's really important that you get all the code. So make sure you come to the top right here and start highlighting from that first comment. Go all the way through your loop. And the last bit, you need to make sure you get that squiggly bracket at the end there. And then you can just copy that. Make that window go down. Come over here and paste it right in here. So what are we looking at? Okay, well, we're looking at our comments right up here at the beginning. And the comments are useful to help us understand what's going on, but they're not really involved in the functioning of the code. What's going to be happening in here is we come along and it creates two numbers, trig pin and echo pin. Now, this is what they used on their default. We're going to change these numbers right here, because on ours, the trigger pin right here comes back to pin 2, and the echo pin comes back to pin 4. Okay, we're just got it hooked up a little differently than they had for their demo. And it creates a couple of variables in here. And the variables are going to store the distance both in centimeters and in inches, and it's going to store the duration of the pulse. Now the duration of the pulse is going to be a long variable because it's measuring microseconds, and depending on how far something away is, the time that the pulse takes to go there could be longer than the number of microseconds that you could store in an integer variable. It also comes in here and sets up your serial port, and it's going to simulate having a serial monitor by displaying the data at the bottom of the window. And then it turns on our trigger pin to be an output and our echo pin to be an input, so that the Arduino knows what we're going to be able to read. And then this loop is the section of the program that repeats, and this is how you activate an HCSRO4. You start with a digital write, make sure that the pin is low for wait 5 microseconds, very, very brief period of time. Give it a very brief tweak high. Okay, so this one's just making sure that the pin is low when you come in, then it goes high for 10 microseconds, and then it goes low again, and that sends a very fast signal out the trigger pin. Pin 2 right here, it goes pulse, comes right down here, and it says, hey, HCSRO4, go and do your thing. Now the HCSRO4 actually has some complex circuitry on it, so it doesn't just send out one sound and get it back. It sends a number of pulses to try and reduce the amount of error, and the signal that you see back coming on the echo shows how long it takes from the time it sends out that pulse for that pulse to come back and be measured on the receiver. So that's what's happening right in here, is we're telling the HCSRO4, hey, go do your thing. Now, when it does that, we then want to be able to read how long it takes for that to happen. And for that, we use a command called the pulse in command. And you can find more documentation on the pulse in command in the Arduino reference. But what you're going to do is you're going to read that pulse in, and this command says that what I want you to do is listen to the echo pin, okay, which we've defined as pin 4. Listen to pin 4, and when it goes high, I want you to do nothing else, just tell me how long it takes for it to go low again. So this is going to time how long the echo pin is high, and it's going to return that value in microseconds. Then it's going to convert that time into centimeters or into inches using those formulas right there, because we know that standard speed of air. If you're in a very moist environment, that might not be the case. If you're trying to build something that works underwater, well, you've got bigger issues than that, but the speed of sound in water is different than in air. But from where most of us live, the speed of sound on most days is going to be very, very accurate, or very reliable anyway. All right, then it prints the data out on our serial monitor, and it waits a minute, and it comes up here, and it loops around and does it all over again. To see it in action, press the Start Simulation button. Now, right now, there's nothing very fancy happening right on here, okay? But we can open our serial monitor down at the bottom, and you can see that it is printing something out. It's printing out 44 inches, 113 centimeters. No, unfortunately, it's not sending echoes out from the monitor and bouncing them off your forehead and telling you how far you are away right there. What you can do is come into this window, click on, let me just drag that around a little bit, and stop the simulation. Let me just reframe this a little bit. We need to see up at the top right here. Give yourself a little bit of room right up here to be able to see things. Restart that simulation. And now you can click on the object, and that's its field of view, and you can change where the target is located. And as you change the target, not only does it show you up there that it's 143 centimeters, but it shows you down here in the serial monitor that your code is actually working. You could take that code, drop it straight onto an Arduino, and if you have an HCSRO4 hooked up this way, then it's going to work exactly like that. So that's pretty cool. We've got the HCSRO4 up and running in simulation on the computer, and you can take a look at how it's measuring distance. Now, I'm going to stop the simulation here. The code is fine, but this code does nothing other than just measure distance. And it uses a lot of code to measure the distance. And if we had this code all stuffed into our void loop all the time, the loop would start to get clogged up a little bit. It would be difficult to read. So what we're going to do is we're going to create a new function that does all the reading for us, and it's going to return the value of the distance in centimeters. So what we're going to do down here is you're going to come in, and after the last bracket in the loop, we're going to create a new function in here. And instead of it being void, because void means we're going to return nothing, we're going to say int, then we're going to call the function range, and we'll do bracket bracket because we're not passing any values to it. Now, if you're using multiple rangefinders, you could have it pass a value over to say which rangefinder to look at, but we're happy to just take a look at one of them. And then we'll put our standard opening and closing brackets in here and leave some space in between the two of them. So what we want to have happen is as soon as we call that function, we want to do our digital write, trigger the pin, so we can cut that out of our main loop and drop it right down here. Okay, just going to hit tab. Okay, that'll align itself shortly. Then what we're going to do is we are also going to come down here, and then we're going to copy our pin mode and duration. And we're going to put that right in there. So now we've got our trigger pin all activated right in here. We've got our pulse in. We measure the time that the echo pin is high. And we're just going to take this. We're going to do our math calculations right down here. And so it's going to calculate the distance in centimeters and inches. And we are going to return a value. And normally we just say return centimeters. But that's going to give us a little bit of a problem because we told it was going to return an integer value, and centimeters is a floating point value. So what we're going to do is we're going to change that, and we're just going to do something called typecasting, and we're going to return the integer value of centimeters to our program. Okay, so now anytime we type in the word range, let's get rid of some of this code down here. And in our void loop, we can get rid of all of this. Now our void loop just has that delay left in it right here. And we are just going to say serial.print brackets range. And we have, because range is a function, we have to put those empty brackets behind it. And now that should print the range. Let's start that simulation and take a look at what's happening. Oh, let's stop the simulation. It was all printing out horizontally because we didn't say print ln. That's how you know it's a good simulator. When it doesn't do what you want it to, it does what you tell it to. Computers are nasty that way. And there we go. So now what's happening in loop is this is running around right here, but every time it comes to this range right here, it breaks out of loop. It comes down to this function that we've created, and it does everything that you need to do to measure distance. It returns that value, and it plunks that number, in this case 51, right in here. And then we pass the 51 to the serial print line function, and it prints it on our display right here. So we can stop that simulation right there. So that's really nice. We're able to take a look at what's going on in there. We're able to print out some data. We're able to measure range. And if you've got that running, that's excellent. So let's see if we can add a few more features to this to make it look good. One of the things that we would want to add is we'd want to add some Neopixels. So let's turn off the code window for a second and scroll up and down here, and there are some Neopixels available. So here's a Neopixel strip of 10 Neopixels, just like we have on that board, and we can drag it up and pop it in right about there. Okay, and if we zoom in on the Neopixels right here, slightly different wiring than I think we've got on our board. We're going to take our ground line, and if you click as you're putting the wires in, you can get these nifty little bends in there. Oh, there we go. Oh, I bent it right in the middle. It's not going to be nice and square. Now, if you're hooking up to ground, make sure you make it black. And if you're hooking up to power, make sure you make it red. Okay, and our data line is going to be hooked up to Arduino pin number 7 because that's how it's hooked up on our main board. Oh, I didn't want to move that. There's an undo button. Wanted to move everything. There we go. And so let's just take that. And we'll bring it down here. Jump across to right here. And into pin 7. And we're already using green for something. Let's make that blue. Okay, so our Neopixels will show up in blue. And now we should be able to add Neopixels into our code. So we can pop that code window open again. And let's get rid of these comments in here so we can see the screen a little bit more easily. Okay, and so this actually has some really neat functions. Libraries. Just like in your Arduino IDE, you can bring libraries in here. So click on the Libraries button, and some of the most popular ones that they've got able to work on here are included right on here. So you can bring in the Neopixel library. And so right at our header here, you can see it says include Adafruit Neopixel.h. Now, whenever I'm using the Adafruit Neopixel library, I like to work with some of their sample code. So I'll open up my Arduino, and in my Arduino code where I've got the library installed, I'll come into examples. And in your examples, you can find Adafruit Neopixel library. And let's just take a look at strand test, because strand test, close that other window, strand test gives you the format that you need in order to make this work. And the first line that you need out of strand test is right here where you set up the Neopixel object. So we can cut that out of the strand test sample for, I guess I could have just copied it. But that goes in with your variables and your definitions right up here before you put void setup in there. Now, if you need a bit more space on the screen, you can drag this out so that you can see everything that goes in there. Now, we do need to make a couple modifications to this. We only have 10 Neopixels, okay? And instead of connecting to pin, which they defined as a number, we know that we're going to connect to pin 7. Okay, so make sure you make those two changes in order to get your Neopixel strip working. Let's take a look at what else is in the strand test code that we might want to copy over. Okay, in our setup, we've got strip.begin and strip.show. Copy and paste that into setup. Okay, so now this is going to run once at the beginning of the program. It's going to initialize that strip, and then it's going to turn everything on the strip off using the strip.show command right here. And what else do we have in here? Strand test. If we take a look down here, that's everything up and running to make it work. If you come down in here, you'll find out how it makes it work. It's got strip.setPixelColor and strip.show. So what we could do, if we just want to test it and see if it was working, we could come in here and go strip.setPixelColor, and make sure I go back and check my capitalization on that. Okay. The first S is small. And let's set pixel number 1 to half brightness. And let's go ahead and start that simulation. Check our serial monitor. We're getting numbers coming out. Okay, but nothing's happening right in there. And I'm going to stop that simulation. Before I answer, can you tell me why nothing's coming out? Well, okay, I wasn't expecting to hear an answer from you directly online. But what you had to do in here is after you put in the strip set pixel color, you need to go strip.show. Okay, what happens when you do strip set pixel color is it stores that color in the Arduino's memory, and it hangs onto it and it says, okay, I'm going to send that data down the line as soon as you tell me. Okay, but I'm waiting until you tell me to update all the colors, because you might have a lot of color updating that you want to do, and then you want to update everything all at once. Let's start that simulation now. And there we go. Pixel number 1 came on. Remember that our pixel numbering starts at 0. Okay, I'm going to stop this simulation right here. Now what we'd like to do is like to be able to turn this into a bar graph so that the farther something away is, the more LEDs are on. And as the object comes closer and closer and closer, the lights turn off until we're right nice and close in there. So what we're going to do that is we're going to create a function. Just as we had a function before, we're going to create a new function right in here. And we'll call this void because it's not going to return any values to us. And we'll call it light bar. Okay. And it's going to accept a variable. So we're going to send something to that. And it's going to be an integer value. And we'll call it range, the distance in centimeters that we're looking at. And then just like any function, it needs to be enclosed in the ellipses, the squiggly brackets, the curly brackets, whatever you want to call them. Okay, now we've got 10 LEDs and we'd like to turn them on if the object, basically let's say first LED comes on at 10 centimeters. And we've got 10 LEDs, so that would range out to 100 centimeters. So what we can do is we can create a little for loop, and we can go through our LEDs one at a time. And we'll create a little local variable that we'll call I, and we'll start it at 0, at the 0th LED, and we'll stop it when it gets to the last LED. The last LED will actually be LED number 9. We're going to go 0 through 9 here, so we use I as less than 10. If we said I is less than or equal to 10, we'd actually get 11 LEDs because we'd have 0 through 10. And the 0 would be our 11th one. And what we'll do is we'll just say I. So this command is going to come along and the for loop will repeat everything in this set of squiggly brackets 10 times, and each time it does it, I will increase by a factor of 10. Okay, so we can say now if range divided by 10, okay, is greater than I. Make sure you type an I and don't get a 1 in there. Range is greater than 10 is greater than I. Then what we want to do is we want to turn that LED on. So we go strip dot set pixel color, and this one we'll set I because we're talking about LED number I. We'll start at 0 and we'll go all the way through, and let's set it nice and bright. Now, if that is not the case, oh yeah, I got to remember to turn my email program off when I do these. But Pacific Breeze makes really nice wine. Else, squiggly brackets right here, strip dot set pixel color I, comma 0. And there we go. So put our bracket right here. So our first bracket right in here should match with this one down here. This one right here matches with that right there. So that's everything within there is controlled by the for loop. This one right here matches with our if statement, or sorry, our else. This one matches with the if. So all of our brackets are accounted for right in here. So when we call light bar and we pass it the range, every 10 centimeters, it should turn on an LED for us. So let's come into our loop right here. We should do a strip.show right after we do all that. Before we go back, strip.show. And let's delete that out of there. And we'll replace it with light bar brackets range. So now what's going to happen is that this is going to go out. It's going to do the serial print of the range data. Then it's going to come back in here and the light bar is going to call the range. It's going to go out, it's going to do another reading, going to get that value, pass that value over to here, and that's going to determine if the LEDs turn on. Let's start the simulation. There, our code is running right now. We're at 51 centimeters, it says, and we see 1, 2, 3, 4, 5 LEDs turned on. We can click on the HCSRO4, and as we come shorter, the LEDs turn off, and as we go longer away, the LEDs turn on. So we've got that working just the way it was working earlier on our real world Arduino. So that's pretty cool. Now, you can play around with that for a little bit. We can stop the simulation right there. And I want to take a look at some other neat features that are happening right in here. So I'm just going to get rid of my code window for a moment. And somewhere down in here, we've got all of our diagnostic tools. And one of our diagnostic tools that's really cool is the oscilloscope, because the oscilloscope lets us see what's happening when signals go by really, really fast. So we can come over here and we can take the negative line right here. Let's just route that over and just plug it into ground somewhere. That'll do for ground. Remember, if it's going to ground, make sure it's black. The electrons don't care, but I do. And then let's take the positive line, and this is the signal that we're going to measure. And connect it to the signal coming in right there. Okay, and we can leave that in green. It's not neither positive nor ground. Actually, we should use blue because that's going to be at the same voltage as the rest of that blue line. Okay, now if we start the simulation, things are going to be running in here, and every now and then you're going to see this little pulse show up right in there. Now, right now this is 1 second across right here. Click on your oscilloscope, and let's change our time division down to microseconds. So we're looking at 100 microseconds. So what we've effectively done is zoomed in on here, and we're seeing a 1 millisecond pulse from side to side. So if you think about this as a timeline, this is at 0 milliseconds, this is at 1 millisecond, and then it just keeps repeating over and over and over again. And you can see that this line goes up high for a little bit of time, but it's kind of fuzzy on the top. There's probably more information in there. Let's take it down and see what happens if we go down to 10 microseconds. Still pretty fuzzy in there. Let's take it down to 1 microsecond. If we zoom in far enough right here, what you can see that your Arduino is doing is it's pulsing this switch on and off very, very rapidly. And these little pulses that are coming down, this blue line right here, are being used to tell the Neopixels what color they should go to. This is the digital encryption, the digital encoding of the zeros and the ones that contain all the color information for your Neopixel strip. So very cool to be able to have access to that kind of ability within a simulator. We can also use this. Let's stop the simulation for a second. And let's delete that line. Let's run a new line over here to the echo line. Okay, and let's go ahead and start our simulation right on there. Well, now we need to play around with that. We need to come out. Let's go to the 1 millisecond, and let's go to the 10 milliseconds. Now we can see a little pulse in there. Let's bring it back to 1 millisecond, and let's go back down to microseconds. Now we can see the pulse stays on too long. Let's go to 100 microseconds. Okay, so what we're seeing right in here is that each division is 100 microseconds long. So the pulse that we're getting back from the HCSRO4 is just over 300 microseconds long. Now, if I take that HCSRO4 and I increase the distance, that pulse length gets longer. And if I shorten the distance, there's a certain range at which the sensor doesn't work. So let's put it right in there. Let's take that down. That's still a little bit too long. Let's set this to 200 microseconds per division and see if we can see the results. Might have to go up to 500. There we go. At 500 microseconds per division, we can see that we're getting a pulse coming in here and that it's turning on and off. Let's see if we can adapt that length. There we go. And so you can see that the pulse length that's coming back on that echo pin is getting shorter as the range gets shorter, and the pulse length gets longer as the range gets further away. So you can see the data both streaming out to the Neopixels and the data coming back into the Arduino, and you can see in a very visual way how it's actually reading that data. That's just amazing to have that ability available in a simulator, let alone one that's available to you free of charge. Okay, so that's kind of cool. Let's get rid of the oscilloscope for right now, and let's add in our final feature. And our final feature is going to be the LCD display. So the LCD display is going to come in here, and we can drop this actually right over top of our Arduino for the most part, kind of like it is on our board. And there's a few things that we need to hook up on here. So obviously ground. Let me move it down just a little bit more because I know where some of these pins are going to go, and this will line up a lot nicer if I take ground out and hook it up to right there. And again, set that to black because it's going to ground. VCC is our positive voltage. We'll set that to red. And right in here, our contrast. I always forget if it goes to ground or to positive. I think it goes to ground. And we don't need, we should set that to black because it's connected to ground right now. And then you've got all of these pins numbered right in here. Now, to make it match to our board that we used in the example, the RS pin goes to the Arduino's pin 13. The enable pin, the E, goes to the Arduino's pin 12. And then our data lines down here, beginning with data line DB4, goes to 11. Do a nicer job of this. DB5, DB6, and DB7 hooks up right there. And that's exactly how we've got the LCD screen hooked up to the sample board that we looked at the beginning of the video. So now what we'd like to do is we'd like to have that the range value displayed on the LCD screen. So let's come to our code again. Okay, and using the LCD screen involves using a library. So you can pop open the library and see, aha, they've got the liquid crystal library. Go ahead and include the liquid crystal library. And you see that shows up right there. And now we can use the liquid crystal library just like any other time. So we can come in here, and I like to use the hello world command, or hello world command, the hello world program. So in your Arduino editor, you can come into examples, and you can go to liquid crystal, and you can open up hello world, and that gives you a great example of how to set up your liquid crystal display. So you can copy that line. We've already got liquid crystal.h included. So let's just copy that right out of there. And again, just as we set up our Neopixel strip right here at the beginning, liquid crystal, and we know that ours is connected to 13, 12, 11, 10, 9, 8. Okay, there we go. And let's take a look at Hello World again for a second. And then in our setup, we have to tell it that we're going to do an LCD begin for a 16-column, 2-line LCD display. So we can pop that into anywhere between the squiggly brackets in void setup. Okay, no need for editing anything up there. And then in Hello World, well, there's your LCD set cursor, your LCD print commands. So now you can go ahead and you can add commands to show the range to your object. Now go ahead and pause this. Go ahead. You can do this without me guiding you, but you sure you got it? Okay, that's good. So in loop, right after we do serial.print line range, you can also come in here and go LCD dot print brackets range, right like so. Okay, and then just so that we don't keep printing over top of ourselves, we can do an lcd.clear command right down here. And go ahead, start the simulation. And there's our range displaying on there, 20. Click on here, we increase the range out to 32. There we go, it says 97 right in there, and we're reading it right in there. And let's make my code disappear for a second. And 9 of our LEDs are turned on right there. So it's really cool. You don't need your Arduino to use your Arduino. There's a whole bunch of neat things that we're going to take a look at over the next little while. What I'm going to challenge you to do is to add a few other features. Can you get your Neopixels to show a different color? Can you get a nicer display right down here? What else can you do? Can you add in some other devices? Can you use your potentiometer? Because you can drag a potentiometer in here and use it as an input. Potentiometers are located right here. You could drag that in and you could wire it into your breadboard and give the, just get rid of that. You could have it set a threshold range, and if anybody gets closer than that threshold range, then all the lights could turn on. Or, unfortunately, we don't have a speaker in this one. It could alert us and a speaker could go buzz. So if you've got a real Arduino that you can work with and a real HCSRO4, then you can have a little alarm that goes buzz, buzz, buzz when anybody gets inside 6 feet of you, maybe. Anyway, so there we go. Today's lesson on the HCSRO4, a very cool ultrasonic sensor, and hope you've all got a chance to play with one for real sometime soon.